Hey, how's it going? Today we're going to talk about GraphQL authentication in NestJS. Specifically, we're going to cover how do you do user signups, how do you do logins, and then finally, how do you actually protect your specific queries with a JWT access token. This is a fairly complex topic that I think is not very well documented, so if you follow through this video, I think you're going to walk away with some very solid fundamentals. All right, we're going to start by creating a new application using the NestJS CLI. If you don't already have that, make sure you install -g at NestJS CLI. Once you have that installed, you can then use that CLI to create a new application. So I'm just going to create one called Nest GraphQL Auth. It'll ask you what package manager you want to use. I use npm. Once that completes, I'm going to open this in Visual Studio Code. All right, once that's open, we're actually going to go back in the terminal and install a couple of dependencies so that we can set up GraphQL for the first time. You're going to need to install NestJS GraphQL, GraphQL at version 15, and Apollo Server Express. The version 15 here is pretty important because I think the NestJS GraphQL package here does not yet support GraphQL 16, so make sure you're using version 15 here. All right, so hit enter there. All right, once that's done, we can start configuring our application to use GraphQL. So we're going to open up the app module here. Notice that it starts out with a controller and a service. We don't actually need those. And you can even just delete those files if you want. So what we're going to do here is we're going to import GraphQL module, and we're going to configure it using the for_root method here, passing an object there, and we're going to give it these two properties. We're going to do auto schema file and sort schema true. What this effectively means is that we're going to do code first GraphQL, which means that we're writing the TypeScript and it's going to generate for us the GraphQL schema. All right, so now we're ready to do some actual GraphQL work. Again, back in the terminal, we're going to generate some stuff. We're going to do nest generate resource users. This allows you to bootstrap a lot of boilerplate for you very quickly. And once you enter that, as you can see, it'll ask you what transport layer are you trying to use. In our case, we're using GraphQL code first. So we'll hit enter there. And it's saying, do you want to generate CRUD entry points? Now I'm going to hit yes here because there are some stuff that I want from that generated boilerplate, and then we'll delete the stuff we don't need. All right, so you'll see that it created a bunch of stuff in a new users folder and wired up our app module. So you'll notice that our app module now automatically has the users module in there. All right, taking a look at some of the user stuff that got generated, you'll notice that there's a new users resolver here, and that has our CRUD entry points, right? So it has like the create, read, update, delete. Now for this tutorial, we're not actually trying to do CRUD. We're just trying to do authentication, right? So we're going to delete the remove and the update user. And we're also going to delete the create user here because we're going to do this later in a different module, in our auth module. I don't want that to be in the user resolver. All right, and we can clean up our imports here a little bit. Similarly, in the user service, we can delete the update and remove in here. We'll leave the create in here because we are going to utilize this later. You'll also notice that we have a new user entity file, and this is going to represent basically the shape of our user. And notice they have an example field in here, which we're not going to use. So let's just rename this to ID. Clean this up a little bit. We'll also add a new field for username since we know we're going to be doing logins later. And in general, we're going to be saving that username in our mock database. Speaking of mock database, in our user service, this is where typically you would create queries in here to actually talk to your database. And you can do that with things like Prisma or TypeORM. I would recommend either of those. Both of those are very good, and there's videos on that in my channel if you want to use those specifically. I want this video to be focused on auth, so we're not going to talk too much about the database. So what we're going to do here is we're basically going to create a mock users database that we can read from and add to as we log in and sign up users. So I'm just going to create a private users array here. And remember, with our entity, we have an ID, so let's do a 1 here. We have a username, and technically we also have a password, right? Because we're going to do login, so they have to have some kind of password. Now I'm explicitly calling this out as not secure because it's not, right? We're not supposed to be storing passwords as plain strings. We're going to improve upon this later in this video, so make sure to stick around. All right, so what I'm going to do here is I'm just going to create another dummy user, and let's change the ID here to 2. Let's give this a username of Maria. Right, so let's start to implement some of these service methods. So to find all, we're really just going to return this users, In our find one here, we're actually going to change this to lookup using the username instead of the ID. So we're going to do username as the parameter here, which should be a string. And then we're just going to do a basic array find, right? If the username matches the passed in username, then return that user. Otherwise, it's going to return undefined. Now our create method here, you'll notice that it's using a create user input, which is one of the things that got generated by our Nest generator. We need to update this create user input to have the fields that we want to be saved in our database, right? So we're also going to clean this up to have an ID similar to our entity, right? And in fact, you can just copy the ID and username from our user.entity and you can paste that in here if you want. But we have an extra field. Remember, we have a password as well that we're going to be saving to the database. Now you might be wondering why the entity doesn't have the password field in it, and that's because I don't want that property to be exposed in our API, right? We never want to return the password in any way. And this will probably make a little bit more sense in a bit here, but let's go back to our create here. So in our case, if our database is just an internal in-memory array, the way we create users is to simply add to it. So for example, if we had a user object that looks like this, taking in the create user input, and typically the ID is generated by the database most of the time, right? If you have like auto incrementing IDs, or maybe you have GUIDs. So we're just gonna do a simulation of auto incrementing integer IDs for a database. So we're gonna do this.users.length plus 1, right? So if there's already 2 in there, that means the next one will be 3. Finally, we're gonna add to our users by doing a push, and then we're just gonna return that created user. Again, let me just clarify, this is a mock database. In a real application, you obviously should use a real database. Some people get pissed at me for not doing things the real way. You know, my job here is to hopefully teach you the fundamentals. I'm not giving you a production ready solution that is for you to figure out. Now, like I said, if you need help with that database stuff, I do have videos on both Prisma and TypeORM in my channel, so make sure to check that out. All right, with that in place, let's actually just run our application at this point and see what does it look like? How does it behave? So we're just gonna do npm run start dev, and I actually forgot to change something here. So in our resolver, our default resolver that got generated, this is still passing in a number ID. So we need to update the args in here to be no longer an ID. It'll be a username, as we said, and it'll be a string. All right, with that updated, you'll notice the terminal is all green now. Now, once your application is running, you have to go to localhost 3000/GraphQL, and that's where our API is actually mounted. So within here, we should be able to start doing some basic queries. So for example, I think if we just do users, and let's bring back the username and the ID, hit the play button here, and we get back our 2 mock users. That just makes sure that our application is running. You'll notice in the file structure that we now have a schema.gql here that got generated, and this is gonna be a mirror of the code that we wrote that represents this schema, right? So we have a user with an ID and a username, and we have a query for user and users, and this is automatically going to be updated for us as we manipulate the code. All right, so let's talk about where do we go from here. So we said that we're trying to do authentication, right? And we haven't done any authentication yet. Now what I want to do is we're going to implement user sign up and logins, and then what we want to do is we want to protect this query, right? We don't want just anybody able to query all of our users. We want them to be logged in, right? So we're gonna do a to-do here to protect this, you know, with a JWT, which we'll do in just a second. Well, in a couple minutes. All right, so now in the terminal, we need to actually start setting up our authentication layer, and we're gonna do that through Passport, which NestJS has really good support for. So we're gonna install a couple of things in here. So we're going to install NestJS Passport itself, and Passport Local. Passport Local is a specific strategy for Passport that's going to allow us to log in using a username and password. Now in our case here, we're doing username and password logins. You obviously could do other ways of logging in, right? Like you can do like Google logins, you can do Facebook logins, Twitter logins, whatever. you just have to swap out the different strategies with Passport to allow that to work. In our case, we're just going to stick with something simple with our own username and passwords. Once that installation completes, we also need to install the types for Passport Local. Once you have those installed, we'll be back in the terminal again, and we're going to generate the new module for auth. This module is going to contain all of our authentication concerns, login, sign up, and stuff like that. We're also going to create a new service for auth. We're going to create an auth service, and then finally we're going to do a resolver for auth. Alright, so if we go back in our code, we now should have a auth directory here that has an auth module. It has an auth resolver that's empty, and it's going to have an auth service. Now our auth service in a little bit is going to be used specifically for validating if a user is in our database and if their login credentials are valid. So we need to create a constructor here that injects user service so that we can actually use the methods that we created earlier, like find one. So what we're actually going to add in this auth service is a validate user method, which, as you can see, is taking in a username and a password because we're doing that type of login. And then in here, we need to provide the logic to actually look up the user and make sure that their passwords match. So we already have the user service, and we already created a way to find if a user is in our database or our internal in-memory array. And that's just user service.find1, passing in that username that was given, right? And remember, this user is going to be undefined if that user wasn't there. Now, to actually check if the passwords match, we're just going to do a basic comparison here. So if the user exists and their password in the database matches the password that we get from our parameter up here, then we're going to return the user. Now, you don't actually want to return the full user object because remember, in our database that includes the password. So make sure that you destructure the password out of that, right? So utilizing the REST operator here, if we do result equals user, right? This result is basically equivalent to the user object, except it doesn't have the password in there. And if the user was not found or the password doesn't match, we're just going to return null, and this is going to signal that this user is not authenticated. They don't exist in our application. And then if you forgot to import the user service like I did here, make sure to add that in. All right, at this point, we're ready to start implementing our local strategy. So within the auth folder, we're going to create a new file in there. We're just going to call it local.strategy.ts. And I'm going to add some code here, and let me explain. So first of all, notice that we created a class local strategy, which extends the password strategy from passport local, right? So this is sort of saying, let's say you have different forms of strategies, right? So for example, maybe you had a Google Auth strategy, then you would replace this strategy with that. Okay, so in Passport, the strategies are swappable. You can kind of hot swap depending on what strategy you're trying to do your logins in. In our case, we're doing username and password, which is what Passport Local is doing, right? That is our strategy. So that's what we're extending in Passport strategy here. In the constructor here, you'll notice that we have a super here, and this is ultimately calling the constructor of the strategy itself. And typically the strategies usually will have a configuration object that you can pass in here. So for example, Passport Local specifically, you can configure, for example, what is the username field, right? Like in our case, we're looking for the username itself, but perhaps in your case, you want that to be email. So you can change this to be username field email, and then whatever other strategy configuration you need to pass to that strategy, usually you do it through this object right here, right? In our case, we're just going to use the default, so we're going to keep this empty. All right, the second thing that each of these strategies need to have is a validate method, and this is effectively the callback, the verified callback of that strategy, and it's going to get the details of, as for example, in this case, a user logs in with the username and password. It's going to call this validate method with that username and password, and then it's our job to take that and verify that those are correct. And remember, we just created the auth service validate user earlier that takes in a username and password. So that's exactly what we're doing. We're going to validate the user right back in here. We're checking if their passwords match. And if it does, we're going to return the user. So it's going to come back here, and we're basically just saying, if we never found the user or their passwords don't match, we're going to say they're unauthorized. All right. And then assuming the user is valid, right? Then we simply return that, and returning it here is going to give us access to that user object, within the context of our GraphQL requests. And you'll see this in action in a little bit. Now, before we move forward, I know someone's probably already asking, like, we already said this is not the best way to actually do security, right? We're just doing plain string comparison here. So early on, we're gonna add a to-do here to make this more secure. All right, so we're gonna come back to this, so don't freak out. All right, so back in our local strategy here, now that we've created this, we need to actually sort of hook it into our application. You know, we basically need to register it. So we're gonna go back to our auth module, and we're gonna add a couple extra things in here. So first of all, our strategy is a provider, so make sure to add that in here, right? And make sure to import that. And then we're actually gonna add another property in our auth module here, which is imports, and we need to add the passport module. Right, so those are two important things that you need to have to get Passport working with your NestJS application. Is you need the passport module, and you need however many strategies that you have. You need to have all those strategies registered as a provider in one of your modules. In this case, we're just doing it all in the auth module. There's also actually one more dependency here that we need to bring in, which is the users module, right? And why is that? It's because in our auth service, remember that we're bringing in user service in here. We're injecting the user service. So we're dependent on that user service being exposed by something. In this case, it'll be the users module. That also means that in the users module, we actually need to make sure that the user service is in the exports so that it's not private. It's able to be used by other modules. So this should be users service. All right, so now that we have that in place, we need to actually implement a way for our users to log in. That's what we're gonna do in our auth resolver, right? Remember, this is still empty. All right, so within here, we're gonna need to inject our auth service. So make sure to import that. And this is where we're gonna implement our login query, right? Which is a mutation. Now, in order to complete this, we need to specify a type here of what does our mutation return, right? So if we had a login response, and we haven't created that yet, if we had a shape like that, we also need to have something in our auth service that actually logs us in and returns a form of login service. So we need something like this dot auth service dot login, right? And there's some obviously key missing pieces here for us to get this working. One is that we need to define what does this login response look like, and two, we need to implement the actual login logic that we have in our auth service. So let's start with creating this login response. So I'm going to create a new DTO folder in auth, and within that I'm going to create a new login-response.ts, right? And this is just going to represent the shape of what our response will be. And to save you some time so you don't have to watch me type it, I just created a class login response, which is an object type, and this is going to bring back an access token, right? We're doing JWT. When the user logs in, we need to return an access token, and then along with that is we're going to return the user object. You know, that way when a person logs in, they have their access token, they also have their user information. All right, so back in our resolver, make sure to import that new DTO. All right, so we defined what we want to return, but we also need to define the input itself, which is, we said we're going to log in with username and password. So we need to define that shape as an input type. So in our DTO folder, we're also going to create a login-user.input.ts. And similarly, I'm going to create something that looks similar to our other DTO, but it's specifically going to be an input type because it's going to be an argument. This is going to be an input for our login query, and that's going to require a username and a password. All right, so we need to provide that as an arg to our login in the resolver. So we're going to do args login user input and then login user input. You know, make sure to import args from NestJS GraphQL, and then make sure to import the login user input that we just created. And then we're going to just forward this login user input down to our login method, which is not yet implemented. So we're going to do that next. So in the auth service, we're going to add a new login. It's going to take in a login user input, import that as needed. All right, so we said that within here we need to return an access token, which we haven't implemented yet. So let's just return the string JWT for now, and we'll go back and implement JWTs here. And then we also need to bring back the user. And where do we get the user? Well, we just do the same find one here. And so we're gonna do find one login user input dot username, right? And that's gonna bring back our user, and we're just gonna return that. Although just like before, you don't want to return the user's password, right? So we're gonna do the same trick we did here to destructure the password, and we're gonna return the result. So we're gonna do user result. All right, so at this point, we've created a new mutation that allows a user to pass in a username and password, right? If you look at our GraphQL schema, you'll notice that there's a new mutation there that has a login user input, which is password and username. But we didn't actually hook it up into our passport strategy yet, right? It's just taking in the username and password and forwarding it down to our auth service here. There's a missing piece. We need to actually do this validate method here that is in our local strategy, which, if you remember, is going to go in and check if the username and password is correct. So the way you would usually achieve that in NestJS is through the use of guards. So within our auth folder, we're going to create a new file, and we'll call this one GQL Auth Guard. And I'll add some code in here, and let me explain. So typically, if you had a REST application instead of GraphQL, you can just use this Auth Guard from NestJS Passport directly with the name of the strategy that you're using. So in our case here, Passport Local. So for example, if this were a REST controller, you would just add in here use guards, and then you'd simply add in Auth Guard Local here from that Passport. So the built-in Auth Guard from Passport. So that's typically what you would do if this was a typical controller REST application. But because we're doing GraphQL, there's a little bit of an extra step. So the reason we're doing an extension here is because Passport Local is actually designed to work for a typical REST application, not really GraphQL, right? So it's a slightly different interface, right? In a GraphQL application, usually you have this context, but in a REST application, you usually have just like a request object, right? So in order for Passport Local to work, it's looking for this request object that includes the username and password in the body, right? But by default, it doesn't have that because it doesn't sort of automatically wire it up from the GraphQL context to the request body, because in GraphQL, you don't have this typical request object. You have the context, the GraphQL context. So what we're doing is we're taking that context and we're creating the request object there that the Passport Local strategy is expecting to have, and we're adding in, as you can see here, we're taking the args, the input from our GraphQL context, our GraphQL mutation, which is going to have our login user input, which includes our username and password, and we're just mapping that to request.body, which is where the local strategy is going to look for those credentials. So you need this for this Passport Local strategy to work for the GraphQL context, right? So this is a major gotcha that if you don't have this, it's not going to work. So make sure to pause the screen if you need to and copy this code, and then let's move from there. All right, so now that we have this GQL Auth Guard, which is an extension of Auth Guard Local, we can now go back into our auth resolver and add in our GQL Auth Guard in here and make sure to import that. So at this point, we have everything that we need to log in. If we go into our terminal, I'm just making sure here that there's no red errors, we didn't miss anything. GraphQL Playground, I'll open a new tab in here, and we now should be able to create a new login mutation. And remember that this takes in a login user input, which we're just gonna put in like this. And what's going on here, right? This is so that we can provide the variables in the query variables panel over here. So for example, we can do input, and whatever we pass in here is gonna go over here, and it's gonna get passed into our login mutation, right? So this is where we're gonna have username and password, And then remember, our login allows us to get the user back as well as their access token. So if we hit play here, it's going to give us back a 401 unauthorized. And why is that? Because we just used a dummy username and password in here, right? If we look into our dummy users database, we've got a username of password that looks like this. So we're going to try that. So I'm going to do Marius and not secure. And if I hit play here, now I get back me, the object from the database that has my name on it, and our fake JWT, right? So we effectively figured out how to do logins, right? So we're now able to log in. So let me summarize the flow, because I know that was a lot and it's probably very confusing to follow. All right, so let's try to follow the flow here, right? So when we send that mutation on the GraphQL playground, we're effectively trying to get down here, right? But before it actually gets down to this actual handler down here, it first needs to go through the guard, right? So if you're not familiar with guards in NestJS, you can just think of them as middlewares, right? They're specifically a middleware that's in charge of checking if a user should move forward or not to the actual handler. So when we call the mutation with a login user input, which is our username and password, it's first going to go through the guard, and our GQL guard is mapping the context to a request object, right, which is our username and password. It's mapping it to a request object that the local strategy is able to parse out and provide to this callback over here. So once it's able to see the username and password in that request object, it's going to trigger validate with those credentials. So now we're in here where we actually validate the user. So within this auth service validate user, we're looking up the user in our user database. We're checking, does that user exist, and does their passwords that they passed in, do they match? So if those two things are true, we then just return the user itself, right? So this just bubbles up back up to returning the user from the strategy. And what happens when you return an object from the strategy, that becomes the user context that you have in every request. That's how we're able to tell who the user is in any GraphQL request, right? So once it sort of goes through that, then it's able to actually continue into our login handler here, which calls this guy to return the user itself, which we did another find here, and then our JWT, which we're actually gonna complete in a little bit here. But that sort of completes the entire flow if you're able to follow. All right, so actually now that we're talking about this flow, I'm realizing that, like I said, from the strategy, when we return the user here, it becomes part of the context. So technically, we don't really need to do this query, this user query again in the login method here in the auth service. We can actually just get back the user from the context. So in our login resolver here, if I add context from NestJS GraphQL, just call that context, the user object that we return from the strategy through the validation is actually inside context.user, in the same way that in Express, if you're doing the same thing, it'll be in request.user if you're doing REST. In this case with GraphQL, you have context and the user is in context.user. So I can actually just do context.user, pass that into login, and then authService.login will change this to actually just taking in user. So let's update this to taking the user entity. Let's clean up our imports here. And we don't need to do this find one anymore because we already have the logged in user from the context. We don't need to find that person anymore. We still have that record handy, and this will be exactly the same as before. So back in our playground, if we try to do the same exact thing and log in, we'll get the same exact response as before. All right, so hopefully that was a good summary of how the flow works. At this point, we just need to further improve it so that, you know, it's a little bit closer to what it would be in a real application, right? We did a lot of like to-dos here that we need to go back to. So let's start with this JWT piece. So ideally, we're able to create a new JWT that we return as part of their login, right? They log in, they get back a JWT. And then moving forward, we check the request if they passed in that access token to see if they're already logged in or not, right? If they're authenticated. That way they don't have to keep logging in at every single time. All right, so before we do that, actually, we don't need this anymore as well, because remember the user context that we return does not have password in it anyways. So we don't need to do this restructuring trick that we did earlier, because we already did that up here, right? So this user already has these passwords stripped out. So we just need to return the user directly. All right, now we can actually start installing our stuff that's going to allow us to do JWTs. So just like we had Passport Local, there is also Passport JWT, right? So we're going to install NestJS/JWT and Passport JWT. So what those two things are, NestJWT is really just a utility package that has a lot of the useful JWT stuff, utilities that we are going to use. And Passport JWT is specifically another passport strategy. Remember, you can use one-to-many strategies, but this one is specifically, we're going to use it to protect our routes so that it's looking for a JWT, and it's going to verify and validate that JWT, and which we'll see this in just a little bit here. One more thing, we're going to install the types for Passport JWT, just like we did with local. All right, with those things installed, what we're going to do here is in our auth service, we want to actually pass in or create a JWT that we're going to return instead of this dummy string that we have here. So to do that, we're going to import JWT service from that thing we just installed, and we're going to have this be injected through the constructor just like everything else, right? So we're going to do JWT service with type JWT service, right? And so we're going to replace this fake JWT string to be a real JWT, and we're going to do that by doing this.jwt service.sign. And we need to provide it with a payload, the payload of our actual JWT. And we're going to do username, user.username. And then usually in JWTs, you have sub to represent the sort of the identifier of that, the ID, right? So we're just going to use user.id for that. All right, so it should look like that. Now, for this to actually work, we need to configure the JWT module. So we need to go back into our auth module, and we're going to add a new import here, which is the JWT module, and we're going to register it, and we're going to provide a little bit of configuration here. So first, we're going to provide a sign-in options. So this is where you can configure things like when does that JWT expire. In our case, we're just going to do something simple, 60 seconds. All right, the next piece of property here that is important to provide is a secret. And the secret accepts a string that is a secret. All right, it's something that you need to keep secure. Right now, I'm just going to give it a hard-coded value. Let me remind you again that this is not a production solution. All right, this is a tutorial. I'm trying to teach you the fundamentals. You don't actually want to hard code this value like this. I would suggest that you maybe pull it out of environment variables so that you can pull this out of process.env and then give it some kind of key like JWT secret or something like that, right? So again, don't freak out. A lot of people freak out when I do stuff like this in tutorials and not do it the production way, right? It's your job to make this production ready. My job here is to just teach you fundamentals. All right, so we need a secret string here. Keep it secret. I cannot stress that enough. All right, so at this point, once you have that JWT module registered, and in your auth service, we're doing this JWT sign. If we go back to our playground and log in again, now it's actually going to give us an access token, like a real JWT access token. Now, if I can copy this and go into, right? So if I paste in that access token into JWT.io, you can see that it's very easily decodable. You can see that we have the username and the ID in there, the sub that we passed in, but it says that it's invalid signature because there's something missing, right? It doesn't have our secret key. That's why the key is extremely important to be hidden, because that's the thing that we add in here to verify that this is correct, right? So if I add hide me in here, which is our super secret key, now it says that the signature is verified. But without that, you can't verify the JWT. So again, keep that string as secure as possible and make sure it is not exposed in any way to your clients. All right, so there's a quick JWT lesson for you. Now we're able to create an access token. The next thing we need to actually do is protect one of our queries with a JWT. We want to say that our, if we go back to our user resolver, perhaps like we said earlier, we want to protect the find all to require a JWT. We don't want anybody to simply get access to this, right? So we want this to respond in a way that without the JWT, it'll just fail. All right, so how do we do that? So remember, we also installed a Passport JWT strategy. That's exactly what it does, is it's able to parse out a JWT from the request, and then it validates and verifies it. So in our auth folder, we're gonna add a new JWT.strategy.ts, and just like before, I'm gonna add in the code in here. Again, we got a class JWT strategy. We're taking now the strategy from Passport JWT instead of Passport local like we did before, and we're extending that. So similarly, like I said earlier, if there's any configuration that you need to do for that strategy, you do it in the super here. So in our case, we're saying here that we're expecting the token to show up in the authentication header as a bearer token. We're going to say don't ignore the expiration. So meaning our token, we said, expires after 60 seconds. If it's 61 seconds or more, then it's going to fail. It's going to say that's not a valid token anymore because it's expired. And then again, this is where we provide our super secret key that, again, I have to remind you, please hide that. Hide me, again, as the name suggests. And then what's going to happen is, as it extracts that JWT from the auth header, it's going to decode that, and it's going to call the validate callback with a payload, right? So payload here is the decoded JWT. It's sort of like what the JWT.io is doing for us, right? And in that case, we just take out what's the decoded and return back a object that again becomes our user context, just like before, right? Just like how the local strategy is returning a user object, our JWT strategy here is also returning another user object, which again is going to be saved in our context under .user, context.user. All right, so now that we have that strategy, just like how we had a guard created for our local strategy, we need to create a guard for our JWT strategy. So again, in the auth folder, I'm going to create a new JWT Auth Guard. All right, and just like before, we're going to create a new class JWT Auth Guard that extends Auth Guard JWT. Again, I kind of explained this before, right? We're extending the built-in Auth Guard, and we need to sort of manipulate it so that we're translating it to work in the GraphQL context. If this was a regular REST application and not GraphQL, then you can just use the Auth Guard directly. But in this case, we have to do this translation so that we're able to use it for GraphQL. Pause the screen if you need to copy this. This is an important gotcha. Otherwise, it's not going to work. All right. And then before we forget, remember that anytime you create a new strategy, you need to register it in a module. So just like we registered local strategy in the Auth module, we're going to register JWT strategy as well. All right, so now for us to protect the user's query in our user's resolver, if I were to add a use guards JWT guard in here and add our missing imports, right? So use guards from NestJS common and JWT Auth Guard from our Auth module. Let's clean up our to-do here because that's exactly what we're doing, right? Let's see what happens now if we try to query users. So back in our playground in our first tab here, we're just going to do our old users query. And if I hit the play button here, it's going to say you're unauthorized because you don't have the access token. That's because it's now with the guard looking for the JWT and the HTTP headers, right? So in the HTTP headers on the bottom here, we need to add authorization, and we need to provide a bearer, and we need to put in our token in here. And where do we get our token from? From the login. So we're going to log in again. It's going to bring us back an access token that was signed using our super secret. Copy that, We're going to paste that in here, and we're going to run this request again. And now we're able to pull back the users. So let's do a quick summary of what happened there, right? We performed a query of users, get users, right? Before it gets down here, again, think of guards as middlewares. It goes through our JWT Auth Guard, which, just like in our local guard, it's gonna translate the request so that this is something that the JWT strategy is able to understand, and it's gonna be able to invoke it, right? So that guard ultimately invokes this JWT strategy. It goes in here, it extracts the JWT from the auth header, as it says here. It'll check to make sure that it's not expired already, and is gonna make sure that the JWT is valid by making sure it was signed correctly using the same secret key that we have. Right, that's how it verifies that it didn't just randomly come from any other, application that generated that JWT. It's actually a JWT that we generated from our login. And once it goes through all that verification, it then calls our callback with a payload of the decoded JWT, and that completes the flow. This returns a user, which makes it available to the context. And then at that point, we're past the guard, and we're now down in this handler, our resolver here, and it's gonna do the find all and return our users array. All right, so I hope that summary makes sense. If you ever have any logic that depends on who the specific user is, right, remember that you can pull in the context like this, and the user will be available in context.user, the user that we decoded in our JWT strategy here, just like we did in the local. Right? So you can use that context.user to access the user's data. And within this JWT, we have a pretty simple object in here of, it's just a user ID and the username. But if you, for example, have a more, larger, more complicated user record in your database, you can do a get user call here, just like how we do it in the local strategy, right? You can do a database call and get back your full user object. And then it's up to you what you return over here to make it part of the context, right? And that context will be, again, it'll be available in the user context.user. All right, so we pretty much were able to log in. We're able to protect our queries with a JWT. There's just one missing thing, right? We said we're also gonna do sign up, which we probably should have done first, but I think it's easier to teach it this way because you're able to see sort of how the logic flows. But now that we have all of these things in the pipeline, all right, so here's what we're gonna do. Back in our auth resolver, just like how we have a login here, we're gonna create a mutation for sign up, right? And this is a mutation which we're just gonna return the user. All right, and we need to have an args here, right? We need an input, which is really, if you think about it, the registration is pretty much the same thing as like a login, except that the password can be anything, right? So we also need to ask for username and password. So really, we can just reuse this login user input in here if we want to. You can, of course, rename it to something else if you want, but let's keep it simple here. And what we're gonna do is we wanna take that username and password and effectively store it in our database. All right, so we're gonna return a this.authService.signup, and we'll pass in that login user input. And similarly as before, we didn't implement signup, so let's go do that in our auth service. So we'll create a new signup method here that takes in a login user input, which again has username and password. And first thing we want to do is probably make sure that this user does not already exist, right? So let's do a real quick check of await this.user service. Let's do a find one, and let's make sure that the username that is passed in does not already exist in our database. So if we actually find a user, let's just throw an error in here and say user already exists. Now, if you're using a real database, what I would recommend is that you actually just use like the unique constraint on the user ID or the username, and that will automatically make it that at the point that you try to insert, it's actually just gonna bubble up an error saying, hey, this already exists. then you don't need to do this explicit query, right? In our case, we have a fake database, so we got to have our own fake way to do a unique constraint. So if the user wasn't found, that means they're new. So we can just do return this.userService.create. All right, so we'll just spread the login user input in here, which has username and password. We have an error here saying our create user input is expecting an ID. That's actually a mistake, I think. So in our user service, we have a create, which is expecting a create user input. We're actually gonna remove the ID field in here because we don't yet have that. That's being created in the method itself, so it's not something that's being passed in. We're doing that down here, right? In a database, again, usually you can do auto incrementing ints. So this user service that create is going to add to our array, basically, right? So it's calling this create method in our user service. It's going to push to the array and it's going to return that user with a new ID in it. All right, so that basically is our sign up. Although I did say that, you know, we want to make this a little bit more secure. We don't actually want to store passwords as plain strings in our database. All right, we had a to do in here. So what we're going to do about that is we are going to install Bcrypt, which is the typical package you would use for this types of situations, right? I recommend you read about this, you know, from the package itself. You know, there's this really good article, how to safely store a password, from Coda Hale. You know, this goes into a lot more detail, and it's a little bit out of scope for this video, so I'm not gonna take a lot of time explaining what Bcrypt is and why you need to use it, but I recommend you look into this article. You know, maybe I'll do that coverage in another video, but basically what it's gonna do for us, it's gonna hash our passwords so that we instead save the hash instead of saving the plain string, right? So in our sign up here, we now have the Bcrypt module installed. We're gonna pull that in, import star as Bcrypt, and down here, if the user doesn't already exist, we're gonna create a hashed password, and we're gonna do that by doing bcrypt.hash, and then we're gonna pass in the password that the user typed in, right? The plain string password. We're gonna hash that, and the hash is actually what we're gonna save in our database, right? And just so you can see this happening, we're gonna add a console log on our create here, just so you can kind of view what our database looks like, right? So we're gonna log out. So we're gonna log out our this.users, and we'll see that in action in a little bit. Just quick check in our terminal, make sure nothing's broken in here, and we're gonna go to our playground and simulate a sign up. The sign up, like I said, is pretty much similar to a login. So we're gonna copy that mutation actually, and let's just rename it a little bit. And we can pretty much also copy this input in our query variables here. And our sign up only returns the user, not the access token. So let's do username and ID. And what I actually expect to happen here is it's gonna fail because this username already exists, right? So when I hit the play button there, it'll error saying user already exists. So let's do a fresh user. Let's just do add a 2 here and change the password to something more secure. I hit play here, and that's gonna sign up, add it to the array with a new username. And if we check our logs, like I said, we're logging out the full array, right? Notice that it added this new object with that new user with the hashed password. So that's significantly much safer than storing the plain string passwords like this, right? But if you're following along, we need to fix something in our code so that when we do the password comparison, we're able to log in with the regular non-hash password, but we need to be able to compare that with the hash password, right? So for example, if I try to log in with my new credentials here, so I'm going to copy this from sign up to login, right? So I'm trying to log in as my newly created user, and I hit play here. It's going to say it's unauthorized because what's happening? Back in our auth service, remember it, you know, through that flow of logging in, it eventually gets to validate user, and it's doing this user password check. So it's actually comparing the password that we typed with the hash password, and it's failing right here because they don't match. So what we need to add in here is we need to bring in Bcrypt again to do that comparison for us. So we're going to do valid equals await Bcrypt.compare, and we're going to pass in, we're going to compare the password, the plain text password that's typed in from our mutation, and the user password, which is the hash password in our database, and it's going to do the comparison for us. And if it's valid, then we move forward. So we're going to replace this comparison with the valid, and I guess there's a scenario where the user doesn't exist, right? So we'll do a question mark there. Now if we go back to our playground, we actually need to do that sign up again, because remember, this is just, our database is just an in-memory array. So every time we type in code, it's actually clearing out any of our new signups. So I'm going to sign up again in here just to make sure that's actually created, right? And it's going to do the hashing for us. And then now if I go back to login with those new credentials, right, with the plain text password, it's going to do the comparison for us in with the hash database password. And if I hit the play here, it's able to log in and get back our our user as well as the access token. All right, so now that's a little bit more secure. Really, the only thing that can be improved upon here, I think, is, like I said, use a real database. That's out of scope for this tutorial. And then finally, make sure that you hide the secret, the JWT signing secret, hide that and put it into environment variables, right? That should be pretty easy for people to do. And then I believe that's it, right? So just to summarize, we've implemented how to log in. Well, first of all, we've implemented how to sign up, which adds new users to the database and takes their password and hashes it, saves that hash password in the database, and then we're able to log in and actually make sure that the password that the user provided matches that hash password in the database. And if all of those are good, the user exists, we're able to log in and we return an access token. And then that access token can be, from a client's perspective, can be stored somewhere else. And then they can attach that to their requests within the auth header, right, like this, which we then sort of extract from any request that is requiring that JWT to exist, right? It's requiring that the user is logged in. We're able to extract that, verify that that's a valid JWT, and then from there, we update our context. Same thing as well for the login. We update the context with the user object, and then we can access that user's information from any of these, resolvers, right? So we implemented login, sign up, and protection using JWT. And I told you what are the things that you need to further improve from this tutorial. And that's it. I think that's it. All right, guys, I think that ends my recording here. Hopefully that was a good tutorial for you. Please let me know what you think in the comments. I very much appreciate any kind of feedback you have, even if it's a bad one. I'll read it. I'll respond to it. And if this was in any way valuable to you, please hit that like button and subscribe. I got more stuff like this to produce in the future. Anyways, with that said, hope you have a great day, and I'll see you in the next video.